Hi, welcome students. We will be looking at chemistry in this session, and you are welcome in this course. As we go through this course, we will start with chapter 1, and in chapter 1, as you can see here, we have what we are calling here matter and change. Matter and change. And then down here we will deal with section number 1. Chemistry is a physical science. Chemistry is a physical science, and the main idea that we will be basing on first will be that chemistry is the study of matter and its processes. As we go through this, let's first of all define what chemistry might be defined as. Chemistry is the study. Chemistry is the study. Chemistry is the study. Chemistry is the study of the composition. Chemistry is the study of the composition, structure, and properties of matter. The processes that matter undergoes. The processes that matter undergoes. The processes that matter undergoes, and the energy changes that accompany these processes. And the energy changes that accompany these processes. So when we will be looking at chemistry in general, we will be looking at chemistry being the study, that is it, of composition and structure and properties of matter. So basically when we are looking at chemistry, we base our discussions on matter. That is, the processes that matter undergoes. So what processes does matter undergo? And the energy changes that accompany these processes. So when we look at processes, we are basically looking at the factors that affect the factors that affect matter. So if we are having matter here, or we are having matter, then this matter goes through different processes. So it will go through processes. As we observe this matter, to know the processes that it undergoes, to look at the effects on the matter, the effects that these processes have, effects on the matter, or come up with the idea of looking at matter as we look at the physical properties properties, and the way these processes affect these physical properties, then we are looking at chemistry. So we use instruments to probe questions. We use instruments, as you can see here in the picture, we are having, this is a balance. We can use a balance, which is an instrument used to measure mass. Then we can also have other, of course, we have also other instruments that we can use. Here we see a sample of DNA placed in a scanning tunneling microscope to produce an image showing the contours of the DNA structure, to produce the contours, the contours of the DNA structure. So basically we are meaning that as we go on to probe or to investigate, as we go on to probe or to investigate, we must be having instruments that we use. We must be having instruments that we use. Instruments may include, as we have seen here, examples being an electron microscope. We can have others like the X-ray, the invisible, the X-ray scanners. We can have very many other probing equipments or probing equipment or instruments that we might use when carrying out probes or investigations. So for example, if we take the scanning tunneling microscope, it reveals tiny structures by beaming extremely small particles called electrons at materials. When electrons hit materials, they scatter and produce a pattern that shows the material's microstructure. So invisible X-rays, called X-rays, can also be used to determine microstructure. So we can use, for example, X-rays. We can use X-rays to probe or to look at microstructures. We could use microscopes also. So the pattern that appear to be analyzed to reveal the arrangement of atoms and other particles that make up the material. So when we are using these probes, we can see the patterns of or the structure that makes up matter. When we are studying chemistry, we go into many details, and the first thing that we will be looking at, first of all, we will look at what are the branches or the different branches of chemistry. As we look at the different branches of chemistry, we are going to outline them here, and they include branches like, for example, the first one is organic chemistry. So here we have organic chemistry. We have organic chemistry. 2, we have inorganic chemistry. 3, we have physical chemistry. 4, we have analytical chemistry. 5, we have biochemistry. we have biochemistry. 6, we have theoretical chemistry. So at first, as people used to study chemistry, they had just categorized it into, they had regarded it as being a physical science. They had regarded it as being a physical science, but with continuous probing, they had to come up with divisions, and these are just but branches that came out to show that there are differences between different structures that were regarded to be part of physical chemistry. So this physical chemistry now has many branches, but the biological and physicals are physical science, these branches often overlap. So these branches will overlap. These branches will overlap. There is no specific one that will stand alone. Organic chemistry is the study of most carbon-containing compounds. For example, study of most carbon-containing compounds, carbon-containing compounds. So when we are talking about organic chemistry, what should come into our mind is basically carbon. So what should come into our mind is carbon. So structures that are made of carbon are the basis of what we are calling organic chemistry. So the study of carbon and the other compounds, or the compounds that it makes, we might regard it as organic chemistry. In organic chemistry is the study of non-organic substances. Non-organic substances. The study of non-organic substances, many of which have organic fragments. Many of which have organic fragments. So when we are looking at or probing bonded to metals, so when we are looking at in organic chemistry, we are no longer looking at the organic chemistry, which of course was based on carbon compounds. Here, though sometimes even in organic chemistry you might come out with compounds which might contain carbon, like carbon dioxide, but these ones are just but a few. Majority of these compounds here in organic chemistry will not have carbon in them. So they may either have just a fragment of carbon bonded to metals, or they may have metals and non-metals. Then we have physical chemistry. So when we are looking at physical chemistry, we are going in another way. When we are looking at physical chemistry, we are looking at something else here. It is the study of the properties and changes of matter. The study of properties and changes of matter. So when we study matter and the changes that it undergoes, it undergoes, and their relation to energy, and their relation to energy, then we will be looking at physical chemistry. So the study of properties and changes of matter, these and their relations to energy is what we call physical chemistry. Then analytical chemistry is the identification of the components and composition of material. The identification, this one is the identification of the components, the identifications of the components of matter, and the composition of materials, and composition of materials. So after probing and categorizing this matter as being either organic or inorganic, and then you go into details and look at its physical chemistry, which will give the properties and the changes. In analytical chemistry, we basically identify the components of matter and the composition of material. So we go into the identifying the components that make up matter and the composition of the materials, that is in terms of maybe I can say in terms of mass or any other units that we might use to analyze and come up with information about matter and the composition and what is composed in it. Then we have biochemistry, which is the study of substances and processes occurring in living things. So here, biochemistry, the study of substances, and processes occurring in living things, and processes occurring in living things. So these processes that occur in living things, we call them, or when we are studying them, we call this study biochemistry. Biochemistry meaning from the word bio, which means life, and chemistry, which we have seen, is the study of the composition and structure of matter that makes up these organisms. So we will be looking at this in living things, and this is what we are calling biochemistry. Then we have theoretical chemistry. In theoretical chemistry, here the use of mathematics, the use of mathematics which is of course also a science, and computers, the use of mathematics and computers to understand the principles, behind observed chemical behaviors. behind observed chemical behaviors. So, behind observed chemical behaviors and to design and predict the properties of new compounds. And to design and predict, to design and predict the properties of new compounds. The properties of new compounds. So, theoretical chemistry comes up and analyzes, after getting the behaviors, then we can use these behaviors to make predictions and maybe come up with another compound which we might not have discovered by the time we are analyzing a specific compound. So computers will help us to understand the principles behind the observed chemical behavior and to design and make predictions of the properties of new compounds. So, as we are looking or studying chemistry, we will be looking at something very important here, and that is chemical. We will be looking at a chemical. So you cannot study chemistry without chemicals. So a chemical is a substance that has a definite composition. Is a substance, is a substance that has a definite composition. That has a definite composition. So a substance that has a definite composition, we might take an example of, for example, sorry for this, for example, we might have sucrose, which is sugar. We can have other examples like carbon dioxide, water, and other countless of substances, So all these substances are chemicals. So knowing the properties of chemicals allows chemists to find suitable uses for them. Imagine if we didn't know the properties of these chemicals, then they would be useless to us. If we don't know the properties, so knowing the properties of chemicals, allows chemists to find suitable uses for them. Allow chemists to find suitable uses for them. This is very essential. In order for us to use chemicals, we must first of all know them. And how do scientists do this? In order for scientists to know or to find out the properties of chemicals, they carry out research. So research has synthesized new substances such as, for example, research has synthesized new substances, for example. So through research, we have come up with new substances like artificial sweeteners, we have, and synthetic fibers, So chemists try as much as possible to help improve our life. So as they discover these things, of course, this helps human beings to live a better life. So the reactions used to make these chemicals can often be carried out on a large scale to make new consumer products. So after carrying out research, then you discover, for example, an artificial sweetener, or you discover a synthetic fiber, then the reactions used to make these chemicals, the reactions used to make these chemicals can often be carried out on a large scale to make new consumer products, So to make new consumer products such as flavor enhancers and fabrics. So we are meaning that the research that chemists carry out help basically to improve our lives. Also, when you produce these consumer products, some people benefit from this, like businessmen who will sell these goods and so forth. And this all shows the importance of chemistry in our life. Chemistry is life, and it affects our life every other day. We will stop there for today. In the next lesson, in the next video, we will be looking at the types of research. We will be looking at the types of researches that exist, and we will look at them one by one.